Welcome to Swam's online lecture series on the topic Database Management System. Myself, Muhammad Ubaidullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University. I am pleased to have you join me today as we explore the fascinating realm of databases, database management system. In the few minutes, we will journey through the data model, database schema, and instances. In the previous session, we have discussed database management concepts and database management architecture. Before proceeding with today's agenda, I would like to discuss some questions that I have given you in the last class. The first question was, what do you mean by DBMS concepts? Explain in brief. The answer is a database management system is a software that organizes and facilitates the storage, retrieval, and management of data in databases. It encompasses essential concepts like data modeling, normalization, and query languages. Data modeling involves designing the data structure, while normalization minimizes data redundancy for efficiency. Query language, like a structured query language, enable user to interact with databases, extracting, updating, or deleting information. DBMS ensure data integrity, security, concurrency control, allowing multiple users to access and manipulate data simultaneously. In essence, DBMS streamlines data handling, fostering efficient and structured information management with an organization. The next question was, what do you understand by DBMS architecture, and discuss all types of database management system architecture? The answer is, database management system architecture defines the framework for data management. It includes one tier, two tier, and three tier architectures. In one tier, all components like the database engine and user interface resides on a single machine, limiting scalability. Next was two-tier architecture, separates the database and application logic, enhancing scalability but maintaining some limitations. The three-tier model further divides the application into presentation, logic, and data tiers, improving scalability, maintainability, and flexibility. Each tier communicates with the other, facilitating efficient data processing. Modern systems often adopt the three-tier approach for its adaptability, making it cornerstone in contemporary database management system architectures. So the agenda of the today lecture is to discuss, first I will discuss data models, next will be database schemas and instances, difference in database schema and database instance. Let's start by understanding what is data model. Think of a data model as a blueprint for our database. It's like planning the layout of a house before it's built. We have different types of models, each serving a unique purpose. A data model in database management system defines the structure of database, specifying how data is organized and the relationships between different elements. It serves as a blueprint for designing databases, including the representation of entities, attributes, and their interconnections. Today we are diving into the detailed descriptions of data model. Within database management system, picture yourself in a vast library filled with an abundance of books, each containing valuable information. Now, think about the challenges of finding a specific book efficiently. That is precisely where data model comes into play. They act as organizational wizards of databases, providing a structured approach to managing information. A data model serves as a blueprint for database, outlining how data will be organized, stored, and accessed. It's like the architectural plan that precedes the construction of house, but in this case, it's all about understanding data. As we venture into the types of data models, think of them as different approaches to arranging and linking piece of information. Consider the hierarchical model as a family tree where data is structured in a tree-like format with clear parent-child relationships. It's effective for certain scenarios but can be bit grid in terms of flexibility. The network model, on the other hand, is a bit model advantageous, resembling a web where everyone is interconnected. Here, data is linked and each record can be multiple parents and children's, providing more flexibility but also complexity. Finally, we have the relational model, a widely adopted approach based on tables, row and columns. It emphasizes normalization principles and uses key to establish relationship. Let us understand types of data model. We are not limited to just one blueprint. There are various types of data model such as the relational model, hierarchical model, and network model. Each model has its own way for organizing and representing data. It's like choosing the right architectural style for our house. Let us start from hierarchical model. In hierarchical database model, data is organized in a tree-like structure with the parent-child relationships, where each parent can have multiple children, but each child has only one parent. This model is suitable for representing hierarchical relationships and is often used in systems like XML databases. The hierarchical model in database management system is like a family tree, offering a structured approach to organizing information. In this model, data is represented in a tree-like structure with each record having a clear parent-child relationship. The parent node can have multiple child nodes, but each child node has only one parent. This simplicity makes it easy to understand and navigate, resembling the familiar hierarchy found in the family structure. However, its rigidity can be a limitation in certain scenarios as the changes to the structure can be challenging to implement. Despite of its constraint, the hierarchical model remains relevant in specific applications where a clear and straightforward structure is essential for efficient data organization and retrieval. Next is network model. In the vast landscape of data organization, the network model emerges as a dynamic and interconnected structure. Picture and digital web where information flows through relationships, creating a flexible and intricate network. Unlike the hierarchical models, a strict parent child hierarchy, the network model allows each record to have a multiple parent and children. It thrives on relationship, fostering a more versatile environment for representing complex connections within a database. While it introduces a certain level of complexity, this model's strength lies in its ability to capture and express the interdependencies that often exist in a real world scenarios, making it an appealing choice for certain type of applications. The network database model organizes data using a graph structure, allowing each record to have a multiple parent and child records, creating a more flexible and complex relationship model than the hierarchical model. It is characterized by interconnected records representing entities and relationship. And the last is relational model. In the relational database model, data is organized into tables with row and columns, and relationship between the tables are established through keys. This model ensures data integrity and support efficient querying through the use of a structured query language. The relational model stands as a cornerstone in the realm of database management system. Picture it as a well-organized spreadsheet where data is stored in table with row and columns, forming a relational structures. Each table represents an entity and the relationship between the tables are established through keys. Normalization principles are applied to ensure data integrity, minimizing redundancy and anomalies. This model is simplicity and effectiveness have made it the go-to choice for managing structured data in various applications. From business databases to online platform, with its ability to maintain clear relationship and support complex queries, the relational model continues to be a fundamental and widely adopted framework in the world of database design. So, after the discussion of the model, it's time to understand two other important concepts of DBMS. Was it database schema? So we discuss about a database schema. A database schema is a blueprint or a structural plan that defines the organization and a structure of database including tables, fields, relationships, constraints, and other attributes. A database schema is a blueprint or a structural plan that defines the organization and structure of a database, including table, field, relationship, constraint, and other attributes. Database schemas. A database schema is a blueprint or a structure plan that defines the organization and structure of a database, including tables, fields, relationships, constraints, and other attributes. It encompasses a set of interconnected elements that define the architecture and layout of a database. Among the primary constituents of a database schema are tables, which represent entities or relationship within the database. Each table consists of columns that articulate the attributes of the data, specifying data types and constraints. Columns within a table can include primary keys, which uniquely identify each record in the table, and foreign keys, establishing relationship with the primary keys in other tables to enforce referential integrity. These keys play a crucial role in maintaining a data accuracy and consistency across the database. Additionally, indexes are employed to optimize data retrieval by facilitating rapid search and storing operation. Constraints such as unique, not null, and check constraints further contributes to data integrity by imposing rules on the allowed values in a specific column. Views provide a virtual layer on the top of table, enabling users to interact with data without directly modifying underlying structures. Triggers, another essential element, are special procedures that automatically execute in response to predefined events such as data modification, allowing for automated actions. A well designed database schema is a pivotal in, in promoting efficiency, facilitating seamless querying, and ensuring the overall integrity of the stored data. It establishes the groundwork for effective data management and provides a structured framework for interacting with and extracting values inside from database. The next is database instances. A database instances is a specific occurrence or a snapshot of database at a particular moment in a time, representing the crucial data stored in the database at that specific point. A database instance refers to the concrete realization of database at a particular point in time. It embodies the data, schema, and operational state of the database as it exists in the memory or in a disk during runtime. At its core, a database instances comprises several key components, the foremost lying the data itself. This includes the actual records, entities, and relationships stored within the database tables. These data entities are structured according to the database schema, which defines the organization, data types, and constraints that govern the data's storage and manipulation. Moreover, the database instance comprises Moreover, the database instance encompasses various system resources and structures utilized by the DBMS to manage and manipulate the data efficiently. This includes buffer and caches for storing frequently accessed data, as well as transaction logs and control structures for ensuring data integrity and consistency. Furthermore, a database instance encompasses the execution environment for processing queries and transactions. This involves the database engine, which interprets structured query commands, executes queries, and performs data manipulation operations on behalf of the users and applications. Additionally, the instance manages concurrency control, ensuring that multiple users or processes can access and modify the database concurrently without compromising data integrity. Importantly, a database instance is a transient in nature, meaning it is initiated and terminated based on system demands or user actions. Instances are typically initiated when the DBMS is started and they persist in the memory or on the disk until the system is shut down or instances is explicitly terminated. Multiple instances of the same data can coexist simultaneously, each operating independently with its own set of resources and data. So, let us discuss different type of database schemas. The first is conceptual schema. A conceptual schema serves as a foundational, abstract representation of the overall structure and organization of a database. It provides a high level conceptual framework that captures the essential entities, attributes, relationships, and constraints within the database without delving into the technical implementation details. This conceptualization acts as a bridge between the real world entities that the databases aims to model and the logical organization of data. Entities within a conceptual schema represent the fundamental real world objects or concepts such as customer or product. And each entity is characterized by a set of attributes that describes its properties. Relationship between entities define meaningful connections reflecting association like owns or is enrolled in. Constraints including uniqueness requirement and referential integrity rules are specified to ensure the accuracy and consistency of the data. Primary keys plays a pivotal role in the conceptual schema by uniquely identifying each instance of an entity, establishing a foundation for relationships, cardinality, and modality, defines the number of instances involved in a relationship and constraints on entity participation, providing clarity on the connectivity and the scope of association. During the design process, the conceptual schema is often represented visually through tools like entity relationship diagrams, ER diagrams, aiding both database designer and stakeholders in comprehending the database architecture. This high level abstraction facilitates the communication between the technical and non technical stakeholders, guiding the subsequent development stages where the conceptual schema evolves into logical and physical schema. The next is logical database. The logical database schema constitutes a crucial layer in the database design, providing a more detailed and structured representation compared to the conceptual schema. This stage translates the high-level concepts of the conceptual schema into tangible and implementable form. The primary component of logical The primary component of a logical database schema includes table, relationships, data types, and various optimization techniques. Tables within the logical schema correspond to entities from the conceptual schema, and attributes become column with assigned data types. Relationships between entities are manifested through the use of foreign key, ensuring referential integrity and establishing connection between the different tables. The process of normalization is applied at the logical level of systematically organized data, minimize redundancy, and enhance data integrity. This involves breaking down large table into a smaller, interrelated one based on normalization form. Physical databases. The physical database schema represents the tangible implementation of database at the lowest level, focusing on how data is stored, organized, and accessed on the underlying hardware. This schema details the specific configurations and structures implied to optimize storage and retrieval efficiency. It encompasses various elements including storage structure, indexing mechanism, partitioning strategies, and consideration for caching and buffering also. Storage structures define the physical layout of data and of storage devices, specifying detail such as file organization and block size. Indexing plays a crucial role in optimizing data such as file organization. Indexing plays a crucial role in optimizing data retrieval by providing quick access point to data location. Techniques like B-trees, hash indexes are implemented based on the specific requirement of the database. Partitioning involves dividing large table into manageable partitions, enhancing query performance, and facilitating efficient data maintenance. Clustering is applied to physical group related data, contributing to improved performance for certain type of queries. Caching and buffering mechanisms such as buffer pools are utilized to store frequently accessed data in memory, reducing the need for frequent disk access and enhancing overall system performance. Data compression techniques be applied to reduce storage space requirement, leading to more efficient use of resources. Concurrency control mechanisms are implemented to manage concurrent access by multiple users or transactions, ensuring consistency and isolation of transactions. File organization details such as formats, block size, and allocation strategies are carefully considered to align with the characteristics of the underlying storage medium. The physical database schema is intrinsic. The physical database schema is intricately connected to the hardware architecture and storage system, and its design significantly influence the performance and efficiency of data storage and retrieval operations. So finally, we are in the situation to understand and mark the difference in the database schema and database instances. Let us start database schema. Now let's zoom in on other crucial concepts in database landscape. The database schema, think of the schema as the master blueprint that defines the structure, organization, relationship within a database. It's like the architectural plan that outlines how different pieces of information are arranged and concerned. In essence, data schema acts as a roadmap guiding how data is stored, ensuring consistency and defining the rules that governs the relationship between the various elements. In essence, the database schema acts as a roadmap guiding how data is stored, ensuring consistency, and defining the rules that govern the relationships between various elements, whether it's stable, filled, or constraints. The schema sets the ground rules for how our database will function, making it indispensable elements in the world of organized and efficient data management. It is the overall description of the database. The schema is same for the whole database, does not change frequently, defines the basic structure of the database, that is how the data will be stored in the schema. The next is database instances. In our exploration of database, let's zoom in our crucial concept that the database instance. Think of a database instance as a snapshot or a living, breathing version of a database at a particular moment. It's like capturing the state of all data, a schema, and setting at a specific point in time. So when you are working with a database, you are essentially interacting with instances. Each instance represents a unique configuration, making it distinct from others. Understanding database instances is the key to manage and manipulating data effectively, as it allows us to grasp the dynamic nature of databases and how they evolve over time. It is a collection of information stored in a database at a particular moment. Data in instances can be changed using addition, deletion, and updation. Changes frequently. It is the set of information stored at a particular time. In today's lecture, we discuss about the data model, database schema, and data instance. Now, let us access your knowledge and track your progress with a few thought-provoking questions. Your answer will not only reinforce your understanding but also serve as a blueprint. Now let us access your knowledge and track your progress with a few thought-provoking questions. Your answer will not only reinforce your understanding but also serve as a valuable gauge of your grasp on crucial topics discussed today. The today's question to test your knowledge are: the first question is, what do you mean by the data model? Explain in brief. The second question is, what do you understand by data schema? Discussed all type of database schema. The third question is, what are the differences between database schema and database instance? The last and fourth question is, what do you understand by database instance, discuss all type of database instance. In our conclusion today, we have navigated the intricate world of database model, peeked into the database schemas, and witnessed the life within the database instances. It is a dynamic chance of In our exploration today, we have navigated the intricate world of database model, peeked into the database schemas, and witnessed the life within the database instances. It is a dynamic dance of structure and reality, much like building and inhabiting a home. I hope you enjoyed this exploration. So keep your study on and exploring.